Hello again, everybody. We are working on homework 2.3, acceleration, and this is going to be question number 4. Now, question number 4 has two parts, part A and part B. I'm going to write down the givens right off the bat, and then we'll break it into part A and part B. So what are we told about this car? Well, our car is traveling due north at 18.1 meters per second. And I think there's a band outside the window. I'm at school here, so if that is too loud, well, we'll just find out later. So, our initial velocity is 18.1 meters per second. So the car is traveling at that speed. And after 7.5 seconds, that's our time. 7.5 seconds. Wow, that's really getting loud out there. We want to find out the velocity if we're given two accelerations. And in A, and by the way, I should go back here and say that our velocity, our initial velocity, is 18.1 meters per second north. That's just designating that it's north. It's in one direction. The way this question is worded, we're given an acceleration for A. The acceleration, I'll just put A, because it's part A, is 1.30 meters per second squared in the north direction. So that means your acceleration is in the same direction as your initial velocity. So that means you should speed up. Your car should speed up. So what is the velocity of the car? What is the final velocity? VFA is, well, we don't know. But acceleration is final velocity minus initial velocity all over the change in time. So VFA, we need to rearrange this equation right here to solve for VF because we're given everything else. We're told the initial velocity, we're told the acceleration, and we're told the time that it takes. So we're going to bring our delta t up with A, or A times delta t, and we're going to add VI to both sides to bring it over to the left-hand side, plus V sub I equals our final velocity. So let's make it a little bit prettier over here. VFA equals VIA, or the initial velocity is the same for both, plus acceleration A times delta t. Oop, that should be an A right there. Sorry. Well, what is that? Our initial velocity is 18.1 meters per second. And we add that to our acceleration rate, which is 1.30 meters per second squared, times, hopefully I can squeeze it in there, times the time, times 7.5 seconds. You guys see that okay? That's actually an S right there. 7.5 seconds, that's our change in time. So our VFA, that is our final velocity of A, should be 27.9 meters per second. We have meters per second here, and when we take our A and our T, remember that A is meters per second, and our time is simply in seconds. So one of those seconds and that seconds squared cancels out. So this second part here is also in meters per second. So they can add together to give us a total of 27.9 meters per second for part A. Part B, hopefully I can squeeze it in here. Part B. Now we're told that the acceleration A sub B is 1.15 meters per second due south. What that really means is that the acceleration is in the opposite direction of the initial velocity. You have a negative acceleration. So the magnitude is 1.15 meters per second, or the deceleration is 1.15 meters per second. But the value of it has a negative in front of it. It's a negative acceleration. So when we put that in, since it is oriented in the south direction, not north, it's going to have a negative sign in front of it. Everything else should be the same. We're going to solve for velocity final B, and that is velocity initial B, which I believe is the same as in A, plus the acceleration in B times the change in time. So our initial velocity in both instances is still 18.1 meters per second, plus, I'm just plugging in the numbers here that should go in these values over there on the left, plus acceleration, which is our negative 1.15 meters per second squared, times, that's the times right there, times our change in time, 7.50 seconds. And again, both of these values, or the units, that turns out to be meters per second, and that turns out to be meters per second. So 18 plus a negative number means our velocity is going to be decreasing. So it's going to be less than 18. So our final answer is going to be 9.48 meters per second. So our VFB is 9.48 meters per second. One thing I should point out to you, and it is a little bit of an error, on the homework sheet for part A it says 27.9 meters per second north. That's correct. For part B, the answer says 9.48 meters per second south. That is an error. That should also be north. The car is still moving north. However, the acceleration is directed in the opposite direction. It is still moving north, just at a lesser speed. So either way, the magnitude of part A is 27.9 meters per second, and the magnitude of the velocity in part B is 9.48 meters per second.